Hi children, today we are going to learn ninth class, second chapter, polynomials and factorizations. In that exercise number 2.4, in this exercise we are going to learn about Factor's theorem. So let us see that what is mean of Factor's theorem. Here the Factor's theorem, if p of x is any polynomial, the degree is greater than or equal to 1 and a is any real number. Then here the two conditions. See, x minus a is a linear polynomial. X minus a is a factor of p of x. X minus a is a factor of given polynomial if p of a equal to 0. So here if p of x is any polynomial, the degree is greater than or equal to 1 and a is any real number, then x minus a is nothing but linear polynomial. X minus a is a factor of p of x if p of a equal to 0. Then here if x minus a is a factor of polynomial p of x, then p of a equal to 0. These two are similar only. See, if one thing happened, if and only if the second one also will be happen. See, if one is true, the second one also will be. See, suppose p of x equal to a polynomial ax square plus bx plus c. Suppose. So just it is a one polynomial. Just think that if x minus a is a factor of this p of x, then here p of a is equal to 0. That means if x minus a is a factor of this p of x, that means if you substitute in the place of x, if you substitute a, if you get that equal to 0, if the answer is equal to 0, then this x minus a is a factor of this p of x. Suppose one more example, see that p of x equal to 2x square minus 3x plus 4. Suppose for example. Then see that this x minus 2. Is this x minus 2 is a factor of this p of x or not? How to check? Simple. If p of 2, here minus 2 no? Then substitute p of 2. In the sense, replace in the place of x 2. If you replace in the place of x 2, if you got this p of 2 equal to 0, if you get, that means this x minus 2 is a factor of this given p of x. Now the second condition is that here if you got p of 2 equal to 0, if answer is if p of 2 equal to 0, then this x minus 2 is a factor. If x minus 2 is a factor, definitely we will get p of 2 equal to 0. Then if p of 2 equal to 0, this x minus 2 is a factor. That's what these two conditions will tell us. X minus is a factor of p of x if p of a equal to 0. Or not, if x minus is a factor of a polynomial p of x, then p of a equal to 0. If p of 2 equal to 0, this x minus 2 is a factor. If x minus 2 is a factor of this, definitely you will get p of 2 equal to 0. That means this is a general example to understand this polynomial factors theorem. Then there are many problems based on this factors theorem. You already know that here if it is x minus 2, the factor will be, see, x minus 2 equal to 0, then x equal to, that means p of 2 should equal to 0. If you substitute this p of 2 in the place of x, if you substitute 2 in the place of x, it should be equal to 0. This answer should get equal to 0. Then this x minus 2 is a factor, or else it is not a factor. So I hope you understood. Now let us do some problems based on the factors theorem, which are there in the exercise 2.4 problems. Overall, there are 10 problems are there in the 2.4 exercise. Let us try to solve all the problems in this video. Then the first bit questions are that determine which of the following polynomials as x plus 1 as a factor. X plus 1 as a factor. That means we have to check, there are 4 internal questions here in this bit. We have to check out of these 4 questions which of the questions, that means which of the polynomials having x plus 1 as a factor. Let us see that the first one, that is x cube minus x square minus x plus 1. This is a polynomial p of x equal to this. Let us see, is x plus 1 is a factor of this p of x or not. So if x plus 1 is a factor of p of x, then p of a, that means here p of 1 should be equal to 0. Here x minus 1, so here minus 1, no, you will get here p of 1 equal to 0. If it is x plus 1, you will get minus 1 here. Suppose 2x minus 3 is a factor. Suppose let us say 2x minus 3 is a factor of this polynomial or not. Then what will do it? This 2x minus 3 equal to 0. Then 2x equal to 3. X equal to 3 by 2. That means p of 3 by 2 equal to 0. You should do it. As we done in the remainder theorem. In the same way we have to do it here. So see, as we solved in the remainder theorem, we have solved some problems in that when x minus 1 is divided the p of x or not. Sometimes x minus 1 divided p of x exactly without leaving a remainder. That means the answer we got 0. At that condition I told you this will be a factor of the given polynomials. Okay, then here we have to substitute. Instead of this, let us find out here p of 1. This p of 1 equal to 0 we are getting or not. If p of 1 equal to 0, then the given polynomial, that means x minus 1 is a factor of this given polynomial, or else it is not a factor. Suppose here what is, let us write the given polynomial p of x equal to x cube minus x square minus x plus 1. Then we have to write p of 1. Let us see, p of 1 cube minus 1 square minus 1 plus 1. Here we can see here minus 1 and plus 1 get cancelled. Here p of 1 equal to 1 cube is 1. Here 1 square also is 1. Plus 1 minus 1 get cancelled. P of 1 equal to 0. Yes, you got p of 1 equal to 0. In the sense, here x minus 1 is a factor of p of x. Therefore, x minus 1 is a factor of p of x. The p of x is nothing but a given polynomial x cube minus x square minus x plus 1 by using factor theorem. By using a factor theorem, we can say that it is a factor of p of x. Then here the second question, we have to see the second question in this. Let me write the second question. It was the second question that x to the power of 4 minus x cube plus x square minus x plus 1. Okay, here let us see that here x minus 1 is a factor of this given polynomial or not. Let us write the given polynomial once again. P of x equal to x to the power of 4 minus x cube plus x square minus x plus 1. So we have to find out the same again p of 1. Here p of 1, if p of 1 equal to 0, it is a factor. That means x minus 1 is a factor of p of x given polynomial. Here same again, minus 1 and plus 1 get cancelled, and the remaining terms we will write p of 1 equal to 1 to the power of 4 equal to 1 and minus 1 to the power of 3 equal to 1 plus 1 square equal to also 1. Here 1 plus 1 is 2. P of 1 equal to 1 plus 1 is 2. 2 minus 1. That P of 1 equal to 2 minus 1 is 1. P of 1 equal to 1. Here it is P of 1 is not equal to 0. P of 1 is not equal to 0. P of 1 equal to some number. So here we can write clearly by using factors theorem. By using factors theorem, we can conclude that here x minus 1 is not a factor of given polynomial p of x. It's not a polynomial factor because we didn't get p of 1 equal to 0. Here p of 1 must be equal to 0. Then only this x minus 1 is factor of this p of x. Okay, now there are two more problems. in this bit. So I want to give you third question for you. Let me solve the fourth one. So here the fourth question is that x to the power of 3 minus x square minus of 3 minus root 3 x plus root 3. Okay, now see that same again. We have to see this x minus 1 is a factor of this given polynomial or not. Let us check that the given polynomial once again will rewrite here x cube minus x square, here minus of 3 minus root 3 into x plus root 3. That means in the place of x we have to replace by 1. So p of 1 equal to 1 cube minus 1 square minus 3 minus root 3 into 1 plus root 3. Okay, let us simplify this. P of 1 equal to 1 cube is 1 minus 1 square is also 1 minus. Okay, here let us multiply with 1 here. 1 into 3 is 3. Okay, now here minus of minus plus. Okay, here minus of minus is plus root 3 plus root 3. Okay, now here let us see that p of 1 equal to 1 plus 1 minus 1 get cancelled here, minus root 3 plus here 1 root 3 plus 1 root 3, that is 2 root 3. At last you got that p of 1 equal to minus 3 plus 2 root 3. Here p of 1 is not equal to 0 you got. So in this way you can say that is a x minus 1 is not a factor of given polynomial p of x. The given polynomial p of x. When you get p of x is a x minus 1 is a factor of this. When you get p of 1 equal to 0, then this x minus 1 is a factor. Okay, then I hope you understood this first bit. Okay, let me solve the second one. The second bit here also same thing we are going to be doing, but see here p of x and g of x both are given. G of x is nothing but a one linear polynomial here. So what is the factors theorem? If p of x is any polynomial where degree is greater than or equal to 0 and a is any real number, then x minus 1 is a linear polynomial, x minus a is a linear polynomial. If it is a factor of p of x, then if p of a equal to 0. That is what factors theorem. You remember the factors theorem. Based on the factors theorem only we are going to be solve this problem. Let us see the second bit, that use the factors theorem to determine whether g of x is a factor of f of x in each of the following cases. Here f of x and g of x, two polynomials are given. We have to check this g of x is a factor of f of x or not. When we can say this g of x is a factor of f of x, when you substitute, when here if g of x is a factor of f of x, then f of, that means f of 1, here g of x equal to x plus 1, that means here p of minus 1 is equal to 0. If you get, that will be, that means you should not get any remainder, it should be equal to 0. When you solve, you have to get equal to 0, then only it will be factor. Let us see first one. Suppose f of x is equal to 5x cube plus x square minus 5x minus 1, and here they have given a g of x. Okay, so if g of x that equal to, g of x equal to, they have given x plus 1, x plus 1, simple, like a same like a before problem only, but they have given a here linear polynomial name they have given as a g of x. If g of x is a polynomial, if g of x is a factor of f of x, if g of x is a factor of f of x, then f of 1 minus 1, f of minus 1 should be equal to 0 because here x plus 1 no, so here plus 1 you get here minus 1, then x plus 1 equal to 0, then x equal to minus 1, so f of minus 1 should be get equal to 0. So let us see we will get or not. First of all let us write f of x equal to 5x cube plus x square minus 5x minus 1. So let us find out the f of minus 1 equal to, f of minus 1 equal to, that means 5 into minus 1 whole cube plus here x plus minus 1 we have to replace. Okay, then minus 5 of minus 1 minus 1. So f of minus 1 equal to, okay, here minus 1 whole cube is minus 1 only. 5 into minus 1, that means minus 1 you multiply 3 times. So you will get minus 1. Or not easily you can identify. If power is the odd number, you will get minus as a sign. If power is even number, you will get plus as a sign. Here plus 1 will get. Minus into minus plus, 5 ones are 5, here minus 1. Let us simplify again. F of minus 1 equal to 5 into minus 5. Sorry, 5 into minus 1 is minus 5 plus here 1, here 5, here minus 1. So here plus 5 minus 5 get cancelled, plus 1 minus 1 get cancelled. F of minus 1 equal to 0. Here f of minus 1 equal to 0, you got it no? Then if f of minus 1 equal to 0, then this g of x is a factor of f of x. Simple. Now, so here g of x is a factor of f of x in this condition. What is g of x here? X plus 1. What is f of x? Here the given polynomial 5x cube plus x square minus 5x plus 1. Here f of x. That means here f of minus 1. If answer you got equal to 0, then it is a factor. Or else it is not a factor. This is what simple thing we have to do it. So there are many questions in this again. In this bit, second bit. So if I solve all the problems, then you don't have any work. So what I will do it? Let me solve the remaining again 1 or 2 questions. Let me solve here the fourth question. That is, here they have given f of x equal to 3x cube plus x square minus 20x plus 12. And they have given here g of x. If g of x equal to 3x minus 2 is a factor of f of x, then here f of dash equal to 0. F of what here? That is what simple here. 3x minus 2 no? 3x minus 2 equal to 0. Then 3x equal to plus 2. Then x equal to 2 by 3. That's here. Simple will get 2 by 3. The 2 by 3. F of 2 by 3 equal to should get 0. Then only this g of x is a factor of f of x. So let us write the f of x is 3x cube plus x square minus 20x plus 12. So f of 2 by 3 equal to 3 into, in the place of x we will substitute 2 by 3 plus x, that is 2 by 3 whole square minus 20 into x. X is nothing but again 2 by 3 plus 12. Let us find out f of 2 by 3 is equal to 3 into here 2 cube is 8 whole by 3 cube is 27 plus here 2 square is 4 by 3 square is 9 minus here 20 into 2, that is 40 by 3 plus 12. Now again let us simplify here. 3 ones are 3 nines are 27. At last we get here f of 2 by 3 is equal to 8 by 9 plus here 4 by 9 minus 40 by 3 plus here 12 will write as a 12 by 1. And let us take the LCM of 9 comma 9 comma 3. We know that the LCM of 9 comma 9 comma 3, that will be a 9. Let us solve now. Here denominators are same, so write the numerators are same by using like fractions simplification. Here minus Let us put the minus. 3 how many are here? 3 3s are 9. So this 3 into 40 is 120 plus 1 9s are 9. 1 9s are 9 and 9 into 12. 12 9s are 108. 12 9s are 108. So let us solve again. This f of 2 by 3 is equal to 8 plus 4 12. 12 plus 108 120. 120 minus here 120 by 9. That is f of 2 by 3 is equal to 0 plus 120 minus 120 get cancelled. 0 by 9. That is nothing but 0. Simple. Here f of 2 by 3 equal to what? 0. Hence here g of x is a factor of here g of x is a factor of f of x. You got equal to this f of x equal to you got 0. Hence g of x is a factor of f of x. If you didn't get equal to 0, that is not a factor. I hope you understood this bit also. Next, let us solve in the same way. We have all the problems in this exercise. Only some of the problems we have division method. Yesterday, that means in the last class, I told you that in the remainder theorem how to find out the remainder. That means how to find out the quotient and divisor and remainder by using long division method. So here also you will get some long division method questions. So I will tell you how to do that. And let us go for the third question here directly. Third question. Show that you have to listen this because third question and fourth question will be very similar. So show that x plus 2 comma x plus 3 comma and x minus 4 are factors. These are factors of polynomial p of x equal to x cube minus 3x square minus 10x plus 24. So we have to check this x plus 2 comma x plus 3 and x minus 4 are factors of this polynomial or not. Simple. First f of minus 2, sorry, p of minus 2 you have to substitute because here plus 2, x plus 2. So p of 2 should be equal to 0 and if p of minus 3 should be equal to 0 and here p of 4 should be equal to 0. Then only these are factors of this polynomial. Otherwise it is not a factor. By using factors theorem, if x plus 2 comma x plus 3, so here we go for the solution now. X plus 3 and x minus 4 are factors of p of x. Then by using factors theorem, we have to get f of, sorry, here p of, here x plus 2 no, p of minus 2 comma here p of minus 3 and p of 4. Here p of minus 2 should be equal to 0 and p of minus 3 should be equal to 0 and p of 4 should be equal to 0. Then only these three will be factors of this. Individually we are going to be find out now. First of all, let us take here the given polynomial p of x equal to x cube minus 3x square minus 10x plus 24. Here we have to find out first what will take p of 2, factor of x plus 2, that means p of minus 2. P of minus 2, let us substitute in this. P of minus 2 this is minus 2 whole cube minus 3 of minus 2 whole square minus 10 of minus 2 plus 24. Let us find out here minus 2 whole cube, that is minus 8, because the power is odd number, no, you will get minus as a sign. 2 cube is 8, power is odd number, so you will get minus as a 8. That means minus you multiply 3 times, you get minus only. Here minus 3 into 2 square, minus 2 whole square is plus 4, and minus into minus plus 10 2s are 20 plus 24. Here let us again solve it. Here minus 8 minus 3 into 4, that is minus 12. Here plus 20 plus 24. Again let us solve it. Here p of minus 2 is equal to minus 8 minus 12 is minus 20 plus here 20 plus 24. Here plus 20 minus 20 get cancelled. Here p of minus 2 equal to what you got? 24. Here p of minus 2 equal to what? You got 24. It is not equal to 0. That means p of minus 2 is not equal to 0. So p of minus 2 is not equal to 0. Then x plus 2 is not a factor of this p of x. This x plus 3 or x minus 4 may be factors that we have to check. But here it is confirmed that x plus 2 is not a factor. Let us write that. Therefore x plus 2 is not a factor of given polynomial p of x. Now next we have to see the one more. P of x equal to what? X cube minus 3x square minus 10x plus 24. In this we have to take x plus 3. If x plus 3 is a factor of this given polynomial or not, to check that we have to get that p of minus 3 equal to 0. If p of minus 3 equal to 0, then only this x plus 3 is a factor of given polynomial. Let us check then p of minus 3. Okay, p of minus 3. Then here minus 3 whole cube minus 3 into minus 3 whole square minus 10 into minus 3 plus 24. Then here p of minus 3 is equal to minus 3 cube is 27 minus 3 into 3 square is 9 minus into minus plus 10 3s are 30 plus 24. Here p of minus 3 is equal to here minus 27, here minus 3 into 9, that is 3 9s are 27 minus 27 plus here you get 30 plus 24, that is 54. Here p of minus 3 is equal to minus 27 is minus 54. Here you will get plus 54. As both will get cancelled, here p of minus 3 equal to 0. In this case, see p of minus 3 equal to 0 you got. Then here x plus 3 is a factor of this given polynomial. You can write here x plus 3 is a factor of given polynomial p of x. Now in the same way we have to check this x minus 4 is a factor of this or not. Let us check that the given polynomial p of x equal to x cube minus 3x square minus 10x plus 24. So to check this x minus 4 is a factor of this polynomial or not, then we must get that p of 4 equal to 0. Then p of 4 will substitute here in the place of x, will replace the 4. Here 4 cube minus 3 into 4 square minus 10 into 4 plus 24. That means here p of 4 equal to 4 cube is 64. 4 cube is 64 minus 3 into 4 square is 16. 4 square is 16. 3 into 16, 48. Here directly I am writing 4 square is 16. 3 16 is 48 minus 10. 4 is on 40 plus 24. Here let us do it here. P of 4 equal to 64 plus 24. 64 plus 24, 88 minus 48 minus 40, that is minus 88. So here p of 4 is equal to you get 0. So here x minus 4 also factor of this. So we are only we get x plus 2 is not a factor of this polynomial. See that clearly x plus 2 is not a factor of this polynomial. The remaining x plus 3 and x minus 4 are factors of this polynomial. Why x plus 2 is not a factor? Because here if you want this x plus 2 is a factor of this given polynomial, then we have to prove that p of minus 2 equal to 0. See that p of minus 2 equal to what you got when you substitute it here. In the place of x, if you substitute p of minus 2 whole cube minus 3 into minus 2 whole square minus 3 into minus 2 in the place of x minus 2, that is 24. So minus 2 whole cube is minus 8 minus into here minus 2 whole square is plus 4. Here minus into minus plus 10 to the 20 and here however plus 24. Then here you see minus here 3 4s are 12 minus 12 minus 8 minus 12 is minus 20. Here plus 20 will get cancelled. At first you got 24. That means here p of minus 2 is not equal to 0 you got. If it is equal to 0 then it is a factor. See in these two conditions p of minus 3 equal to 0 and p of 4 equal to 0. So if p of minus 3 equal to 0 then x plus 3 is a factor of given polynomial. If p of 4 equal to 0 then this x minus 4 is a factor of given polynomial. I hope you understood, because the next question, the fourth question will be the same model. So only these factors are given different and polynomial is given different. But the process is same. You have to check the same way. Then you try to do that question. Let me go for fifth question. Let's go for the fifth question. Very simple questions. Only substitutions and simplifications you should know it. You know the simplification, then you can do this exercise in simple way and scoring also. This polynomials and factorization chapter is very useful in your 10th class also. So practice properly. Let us see the fifth question. Both x minus 2, if both x minus 2 and x minus 1 by 2 are factors of px square plus 5x plus r. Show that p equal to r. Show that p is equal to r. We have to show that p equal to r. So if this 2 x minus 2 is a factor of this px square plus 5x plus r, and also here x minus 1 by 2 is also factorizations. That means here p of 2 equal to 0 you will get, and here p of 1 by 2 equal to also you will get 0. So see that given that in the solution the given polynomial p of x equal to px square plus 5x plus r. Okay, again also they have given here x minus 2 and x minus 1 by 2 are factors of p of x. Then if the x minus 2 is a factor of this p of x, then p of 2 and p of 1 by 2 equal to 0. So by using factors theorem, if x minus 2 and x minus 1 by 2 are factors of p of x, then what we have to get, see here, p of 2 and p of 1 by 2 equal to 0. P of 2 equal to 0 and P of 1 by 2 equal to should get 0. So first of all, let us check. Now we go for the solution. That let us take this P of x. Now where P of x equal to px square plus 5x plus r. This P of x will equal to 0. You will get, definitely will get equal to 0, because already they have given these two are the factors. So here P of x equal to 0. So here P of x is equal to 0 where at P of 2. So here in the place of x I am going to be substitute 2. then this P of X I am going to make it equal to 0. So P into, in the place of X, 2 square plus 5 into 2 plus R, that equal to 0, because this will definitely equal to 0, because already they have given this is a factor. These two are the factors of given polynomial. So they are factors, no? If these two are the factors, if these two linear equations are factors of the given polynomial, definitely you will get P of A equal to 0. That means here P of X equal to 0 you will get here. Let us solve this. P into 2 square is 4. 4 into P, that is 4P. 2, 5 2s are, that is 10 plus R equal to 0. Okay, now here plus 10 will transfer this side. What happens? Let us see here. 4P plus R, that is equal to minus 10 you got. This you keep it as a equation number 1. And let us solve it again. Here let us take it again. P of X polynomial, that is Px square plus 5x plus R. In this case let us take it. This P of X equal to 0. At what? Here P of 1 by 2 equal to 0. Okay, at P of 1 by 2. This P of X equal to 0 at P of 1 by 2, because here X minus 1 by 2 is a factor. So what I am going to do it here, in the place of X I am going to put 1 by 2. So P of 1 by 2 whole square plus 5 into 1 by 2 plus R equal to 0. They are made it equal to 0 because already they are factors. If they are factors, definitely that will be equal to 0. So P of 1 square is 1, 2 square is 4. P into 1 by 4 plus 5 ones are 5 by 2 plus R equal to 0. Let us see here. P into 1, P by 4 plus 5 by 2 plus here R by 1 equal to 0. This R that is R by 1. Let me take a LCM of this now. What I am going to take here, LCM. So LCM will get 4. 4 ones are 4. So it is P plus 2 2s are 4. Then this 2 into 5, 10 plus 1 into 4. That 1 4s are 4 and 4 into R, 4R, that equal to 0. And this 4 is dividing. So we will transfer the other side so that it will be multiplied. Yes. So let us write now what is here. P plus 10 plus 4R equal to 0 into 4. 0 into 4. 0 into 4 will be 0. This plus 10 will transfer this side so that P plus 4R equal to this plus 10 become minus 10. So this is equation number 2. Now we got equation number 1 and also equation number 2. From equation number 1 and 2. From equation numbers 1 and 2, see that both the RHS are equal. Here RHS is minus 10, here also RHS is minus 10. So both the RHS are balanced. So we have to make it LHS are equal now. So let us make it LHS are equal. Here we have LHS of the first equation 4P plus R, and we have LHS of the second equation is P plus 4R. So what I am going to do is this. P I will transfer one side, R's I will send one side. So here 4P, here plus P become minus P here this side, and here there are already 4R and this plus R become minus R this side. So here 3P equal to, here you will get 3R. 4P minus 1P is 3P, 4R minus 1R is 3R. 3 and 3 will get cancelled at both the sides so that we will get P is equal to R. So this is what we need to show that P is equal to R. We got it, the P equal to R or not? Yes, exactly we got it. So here we need to understand one thing. Already they have given that x minus 2 and x minus 1 by 2 are factors. So we have to make it equal to 0. That means P of x is already 0 here. When you substitute P of 2 and P of 1 by 2, definitely we will get the polynomial equal to 0. Because already they are factors. I hope you understood this question. If you have any kind of doubt again, what we have to do it, write the question in the notes, stop watching sometime and try to solve this problem so that you can experience your answer when you are doing it. Better you have to practice 2 to 3 times of this kind of problems, then you don't have any kind of doubts further. Okay, let me go for 6th question. The sixth question is here. If x square minus 1 is a factor of ax power 4 plus bx cube plus cx square plus dx plus e, then show that. Here see that if x square minus 1 is a factor of ax to the power of 4 plus bx cube plus cx square plus dx plus e, then show that. What we need to show that means we have to get this as an answer now. So what we have to get an answer here? A plus c plus e equal to b plus d, that equal to 0. That means here a plus c plus e equal to, you have to get 0, and b plus d should be equal to 0 you have to get. So let us see that what is the given polynomial. That is the given polynomial here ax to the power of 4 plus bx to the power of 3 plus cx square plus dx plus e. So he already given that here x square minus 1 is a factor of this given polynomial. So let's do the solution. The given polynomial is p of x equal to ax to the power of 4 plus bx to the power of 3 plus cx square plus dx plus e. So here already given x square minus 1 is a factor of this given polynomial p of x. So here x square minus 1, in the sense, see, same this x square minus 1 is in the form of, like I can write here x square minus 1 square. X square minus 1 square. This 1 I will write as a 1 square. So that it will be in the form of like a square minus b square. So I can also write this as a plus b into a minus b. Now x square minus 1 square. X square minus 1 I rewritten as a x square minus 1 square. So this x square minus 1 square in the form of a square minus b square. Now we can write this as a x plus 1 and x minus 1. X plus 1 and x minus 1 are the factors of p of x. So not only this x square minus 1 is nothing but a x plus 1 and x minus 1 are the factors. Now we got two factors for this given polynomial. So what we have to do is, first of all let us take if this x plus 1 and x minus 1 are factors of p of x, then we get here p of, for x plus 1 we get p of minus 1 equal to 0, and here for x minus 1 we get p of 1 equal to 0. So both we have to check it now. That means this polynomial, when you substitute in the place of x, if you substitute p of minus 1, it will be equal to 0, and here if p of 1 in the place of x, if you substitute 1, that will be equal to 0. Already this x square minus 1 nothing but x plus 1 and x minus 1 are a factor. So what we are going to do it now, let us see. Now the polynomial p of x is equal to ax to the power of 4 plus bx cube plus cx square plus dx plus e. Here p of x is equal to 0 at p of 1 at p of minus 1. At p of minus 1 once and at p of plus 1 at one other times. So what we have to do it, instead of here x I am going to substitute minus 1. A into minus 1 whole to the power of 4 plus b into minus 1 whole to the power of 3 plus c into minus 1 whole to the power of 2 plus d into minus 1 plus e, that equal to 0 because already it is a factor. So these two are the factors. Already x plus 1 and x minus 1 are the factors. Then here it will be equal to 0. Let us solve it. Here p into minus 1 whole to the power of 4 is only 1 plus here b into minus 1 whole to the power of 3 is minus 1 plus c into minus 1 whole square is nothing but a 1 plus into minus is minus, d into 1 is d minus d plus e equal to 0 here. Let us see, a into 1 is a plus into minus is minus b plus here c into 1 is c minus d plus e equal to 0. Here the which are the terms are in the negative, see that only b term and d term are in the negative. So this both the terms will transfer the other side of the RHS side. Okay. Then the leftover terms are a plus c plus e equal to what? Here minus b become plus b and minus d become plus d. So b plus d. This is what you got equation number 1. So one side you got it a plus c plus e, you got this side. Then we have to make it equal to 0 actually. Let us see what we are going to get again in the further. So step by step if you do it, you get it. So now again let us write our the given polynomial p of x equal to a x to the power of 4 plus b x to the power of 3 plus c x square plus dx plus e. So here p of x is equal to 0 at p of plus 1. Here p of plus 1, p of minus 1 equal to 0, already we done it, p of plus 1 now. So instead of x we are going to be put plus 1. So a into 1 to the power of 4 plus b into 1 to the power of 3 plus c into 1 square plus d into 1 plus e equal to 0. With 1 you multiply, you get the same, that a plus b plus c plus d plus e equal to 0. Here you got it. So this is equation number 2. You got equation number 1 and you got equation number 2 now. So what we have to do is, see that equation number 1 value, that means a plus c plus e equal to b plus d. So let us substitute equation number 1 a plus c plus e equal to b plus d in equation number 2. That means this a plus c plus e value, that is b plus d, we are going to be substitute in this equation number 2. What is equation number 2? Let's write a plus b plus c plus d plus e equal to 0. Instead of this a plus, so I am going to be rewrite this c. I am going to be rewrite like all terms are plus terms. So a plus c plus e plus b plus d equal to 0, right? So these three are write together, because here from the equation number 1 a plus c plus e equal to b plus d, no? So I am going to be put here b plus d. So here b plus d. So instead of this a plus c plus e equal to b plus d, and here already there is a b and here already there is a d, that equal to 0. So 1b plus 1b, that is 2b, plus 1d plus 1d, that is 2d equal to 0. So what happens, you see now, here 2 if you take out a common factor, here b plus d will be left over, that equal to 0. If 2 you take out a common, then here b plus d will be left over. This 2 you transfer this side, then b plus d equal to 0 by 2. Here 2 is multiplying, so 2 will be divided. So 0 by 2 is nothing but 0 1. So here you got it that b plus d equal to 0. Here you got b plus d equal to 0. That means here you got b plus d equal to 0. Now we have to make it a plus c plus e equal to also 0. So for that, what you need to do is this b plus d equal to 0. Let us substitute this. Okay. Let us substitute b plus d equal to 0 in equation number 1. If you substitute in the equation number 1, see that what is equation number 1? A plus c plus e is equal to b plus d. Where b plus d equal to 0, no? So a plus c plus e equal to 0. Now here also you got equal to 0. That means a plus c plus e equal to 0 and b plus d equal to 0. Both terms equal to 0, no? Now we can write the therefore that a plus c plus e plus equal to b plus d, that equal to 0. So that is what we have got it here. So hope you understand the simple here x square minus 1. Here we have to get an idea that it is in the form of a square minus b square. That means we can write this x square minus 1 in the form of x plus 1 into x minus 1. So once we have to substitute plus 1 in the given polynomial, The next time we have to substitute minus 1 in the given polynomial. From that we will get our answer. So just simple, we have to think. Okay, then let us go for the 7th week. In the 7th week there are 4 internal questions are there. Let us try to solve the 4 internal questions of the 7th week. Here 7th week we have to factorize. We have to factorize. Okay, we have to factorize here. Let us factorize this factor by trial and error method. Trial and error method in the sense, at what value this given polynomials will be equal to 0. That we have to find out. So first question is what it is. Let us see. X cube minus 2x square minus x plus 2. So this is a polynomial, that is p of x equal to polynomial, suppose. This p of x equal to. Let us see at what value this polynomial equal to 0, and we have to find out by the factor theorem and as well as for the long division method. Both we have to check. Let us check once. So if you go for this, what we have to do it here. If p of 1, if you substitute where p of 1, what you get? If p of 1 is equal to 0 or not, let us see. If x equal to 1, if x equal to 1, let us see. If x equal to 1, what happens here? P of 1 equal to 1 cube minus 2 into 1 square minus 1 plus 2. Here trial and error method we are following. So once we substitute plus 1, if it is equal to 0, no problem, we get a 1 factor. If it is p of 1 equal to 0, then x minus 1 is the factor. If p of minus 1 equal to 0, then x plus 1 is the factor. That means we have to go for trial and error method. Once you substitute plus 1, if it is not equal to 0, then you substitute minus 1. If it is not equal to 0, again you have to substitute plus 2 and minus 2, plus 3 and minus 3, until you have to get 0. Until you getting a 0, you have to follow this process. This is called trial and error method. This we have learned in the 6th class. So let us see. Here p of 1 equal to 1 cube is 1 minus 2 into 1. 1 square is 1 minus 1 plus 2. Okay, here p of 1 equal to 1 minus 2 ones are 2 minus 1 and plus 2. So here plus 2 minus 2 plus 2 minus 2 get cancelled, plus 1 minus 1 get cancelled. Here p of 1 equal to 0. Yes, you got here p of 1 equal to 0. So here x, if see that if p of 1 equal to 0, then if p of 1 equal to 0, then here x minus 1, because here plus 1, no, here x minus 1 is a factor of p of x. So here p of 1 equal to 0, you got it. Here itself you stop it. If this p of 1 is not equal to 0, you have to substitute p of minus 1, then again you have to try it. So see, so here x minus 1 you got as a factor. Let us see that here there is a cubic polynomial. It has 3 factors actually. The remaining 2 factors we are going to find out. Here we got only 1 factor. The remaining 2 factors are what? That we will find out here by the division method. By the division method. To do the division method yesterday, that means in the last class I told you that the degrees of the polynomial should be in the descending order. The degree here 3, next term 2, next term 1 and constant number. So it is in the descending order only. Let us write as it is x cube minus 2x square minus x plus 2. So let us try this. So what is the one of the factor here? X minus 1. So I already told you there will be a much rough work. The rough work we need to do it step by step. Here first step is what? First term is x cube. This x cube we have to divide by the first linear polynomial, first term, that is x. So here there are 3x, here 1x. Let us cancel 1x and 2 more x will be left here, that is x square. Let us write the x square here. Now with this x square we have to multiply both the terms here. So when you are multiplying the first term and first term, here x square into with first term, we have to get this term same. So x square into x cube. That means you got equal here. Always you will get the first term same. Minus 1 into x square minus 1 x square. So here plus x cube plus x cube. Both cannot be cancelled now. So what we have to do? The second polynomial we have to multiply by minus. That means we have to interchange the symbols of every term. So here plus x cube minus x cube get cancelled. So here minus 2x square, here plus 1x square. 1 minus 2, that is minus 1 x square minus 1 x square, and here we have to bring down the remaining two terms, that is minus x and plus 2. Again the same process we have to be continued. What is the first term here? The second step here, minus 1 x square by the first term we have to divide, that is x. Here 1x and 1x get cancelled. Here minus 1x is left. That means minus x is left. Minus 1x or x is same. So minus. So we get minus. Okay. Minus 1x or minus x. Okay. Both are same. So x into x, that is x square. How many x squares? Only 1 x square. Both the terms we got same again. Minus into minus plus 1 into x is x. Okay, now see that here minus 1x square minus 1x square. Both are similar terms. We cannot cancel. So we'll change the signs here. It become a plus, it become a minus. Now you can cancel this. See, minus 1x minus 2x plus one more term is left, that is 2. We'll rewrite here. Again the process has to be continued. So here minus 2x by, we have to divide by first term, that is x. X's get cancelled, that equal to minus 2. That minus 2 we have to write. Here is our quotient. And with that only we are going to get other two factors. So same, minus 2 into x minus 2x minus 1 into minus 2, that is plus 2. Minus into minus plus 1 to the 2. And here it become a plus and it become a minus here. Plus 2x minus 2x get cancelled, plus 2 and minus 2 get cancelled, we will get 0 as the answer. Now here we know that this, like by the division algorithm, from the division algorithm, dividend equal to divisor into quotient plus remainder. Here it is a dividend, it is divisor, it is a quotient, and we got the remainder. So by that rule, here I can write now, yes, dividend equal to divisor into quotient plus remainder. This is the division algorithm formula. No? So what is the dividend here? That is x cube minus 2x square minus x plus 2. That equal to divisor. What is the divisor? X minus 1 and into, okay, what is the quotient here? X square minus x minus 2. So here x square minus x minus 2. So this we have to find out the other two factors of this. From this, how can we find out the other two factors? In the sense we have to split the middle term. So splitting middle term process is very important. You listen here. For that we need to multiply the x square and the first and last terms. Here minus 2 into x square minus 2x square. First and last term we have to multiply. And this term, that means here minus 2 able to write as a product of any two numbers. So as we can write here 1 to the 2. 1 to the 2 we can write it. But here x into x square. 1 to the 2, x into x square. It is balanced. But minus 2x square no. See that here minus x is there. So here if you put minus, see that here it is a plus, here it is minus. Plus into minus is minus 1 to the 2 x into x square. Now this one we got by the product of first and last terms. Okay, by the first and last term we got this. There are 3 steps only. We have to listen very carefully. Here. First and last terms we have to multiply. The product of first and last term is minus 2x square. This minus 2x square we have to write as a product of any two numbers. Okay, any two numbers. The two numbers, that means here we got the two numbers 1 and 2 plus 1x into minus 2x is minus 2x square. Then if you add or subtract these two numbers, you have to get the middle term. If you add or subtract these two terms, you have to get the middle term. This is called splitting middle term or factorizing method. Okay. So now here, see that here x square, this minus 1x we will write as a plus 1x and minus 2x. So minus 1x minus 2x is minus 8. That means this for this term I split as a plus 1x minus 2x. For this we have done this process actually. Okay. I hope you understood now. Here x minus 1 into, in these two terms we can take out x as a common factor. In these two terms we can take out x as a common factor. Then in this x is left and in this only 1 is left. Out of these two x's I have taken 1x common. So 1x is left. Here only 1 will be left over. And minus 2 we have to take out common. Then x plus 1 will be left over in that. So at last we got x minus 1. Here we have to take out x minus 1 and x minus 1. Both are same. So here x minus 1 will take out common. Sorry, x plus 1 if you take out common, x minus 2 will be left over. So if you x plus 1 is x plus 1, both are same. So x plus 1 I took as a common here, then x minus 2 is left over. So the remaining three factors, the factors of here, the factors of, therefore factors of x cube minus 2x square minus x plus 2 are, what are the factors here? X minus 1 is a factor and also x plus 1 is a factor and x minus 2 is a factor. That means x minus 1 is a factor of this. That means if you substitute x p of 1 will get equal to 0. Already we got. Here p of minus 1 also equal to 0 will get. Here p of x minus 2 is p of 2 also will be getting equal to 0. So here by this long division method we got this 2 actually. Or else you can also go for trial and error method. Plus 1 you got equal to 0 or not. If plus 1 equal to 0, then p of minus 1 is equal to 0. That means p of minus 1 is one of the factor. Then next we have to substitute minus 1. If p of minus 1 equal to 0 if you got, that means p of x plus 1 is a factor. Then plus 2 minus 2 and plus 3 minus 3. You have to continue this process until you get the 3 factors. That is very long method. So further to avoid that, only one factor we are finding here. From this we are dividing the given polynomial. So we are dividing the polynomial by the division method so that we get one quadratic polynomial here. This quadratic polynomial if you split into the two terms by the splitting method will get the other two factors. Very simple way. But this division method is very important. Further I taught you this. Okay. Let me solve the one more problem. Let me solve the one more problem from this bit so that you will get understand that here. So there are 4 problems. 2 problems you do it. The 2 more problems I will teach. One problem is completed. So one more problem I am going to teach you that in the same model I am going to tell you. So if you have any kind of doubt here you can clarify that. So let me go for the second one. In 7th bit only. Okay, the second one is polynomial p of x equal to x cube minus 3x square minus 9x minus 5. So let us see. We have to find out the factors. There will be 3 factors for this. We have to find out the factors here. 3 factors. What are the 3 factors? By the trial and error method, first of all, let us see if p of 1. If p of 1. So if x equal to 1 suppose. If x equal to plus 1 we will take it. If x equal to plus 1 what happens? Let us see. If p of 1 equal to 1 cube minus 3 into 1 square minus 9 into 1 minus 5. So here p of 1 equal to 1 cube value is 1. 3 into 1 square value is 1 only. 3 into 1 is 3. That is minus 3 here. Here minus 9 and minus 5. So if you see here p of 1 equal to minus 3 minus 9 minus 12 minus 17. 1 minus 17 that equal to minus 16. That means here p of 1 is not equal to 0. Here p of 1 is not equal to 0. That means here we have to neglect this. Now what we have to take? If p of 1 is not equal to 0, then if there x equal to 1, it is not equal to 0. That p of 1 is not equal to 0. Then we have to take if x equal to minus 1. You take x equal to minus 1. You have to try it for the one factor at least. If p of x equal to 1, it is not equal to 0. Then x equal to minus 1 you take it. If x equal to minus 1 also it is not equal to 0, then you have to go for x equal to 2 and x equal to minus 2 until you get 1 0. So let me go for that. P of minus 1 equal to, that means x cube, that means minus 1 whole cube minus 3 into minus 1 whole square minus 9 into minus 1 minus 5. Let us see here. P of minus 1 equal to, minus 1 whole cube is minus 1. Here minus 3 into minus 1 whole square is plus 1. Minus into minus plus 9 ones are 9 minus 5. So here 3 ones are, you get 3. So let us solve here. P of minus 1 equal to minus 1 minus 3 minus 4 minus 4 minus 5 minus 9 minus 9 and here plus 9. Both are get cancelled, that equal to 0. Else P of minus 1 equal to, you got 0. Here P of minus 1 equal to 0 in the sense, if P of minus 1 equal to 0, if P of minus 1 equal to 0, then here x plus 1, P of minus 1, no? So here x plus 1 is a factor of this P of x. X plus 1 is a factor. So one of the factor we got now. With this factor we are going to be divide this given polynomial now. So as it is. So we are going to be divide. Let us divide. Okay. Here x plus 1. And let us see. Here the given polynomial having the powers in the descending order. 3, 2, 1, 0. The powers. So as it is we are going to be write now. If powers are in the not in descending order, we have to replace the missing order. 9x minus 5. So here let us find out the division process. Already I told you that the rough work will be more in this. So rough work will write at the right side always. So here first step, you take the first term, that is x cube. We have to divide by the first term, that is x. 1x. Here 2x will be left, x square. So x square. Now let us multiply x into x square, x cube. Here plus 1 into x square plus 1 x square. So here we have to change the symbols to cancel these first two terms. Then here minus 1 minus 3 minus 3 minus 1, that is minus 4 x square, and here the remaining two terms are minus 9x minus 5. So same again the second step here, minus 4x square by x. Here 1x and 1x get cancelled. Here minus 4x will be left over here, minus 4x. Now let us multiply here. Minus 4x into x minus 4x square. Always this first term you will get same. And plus 1 into minus 4x is minus 4x. Here it become a plus and it become a plus again. These two will get cancelled here. 4x minus 9x is minus 5x. And here there is a minus 5. Again the third step will be follows the same process. Then we get the minus 5 here. Let us write the minus 5. Minus 5 into x minus 5x. Again you got the same. Yes, plus into minus is minus. 1 5 is 5. So we will change the signs. See, plus 5x minus 5x get cancelled. Plus 5 and minus 5 get cancelled. That equal to 0. Simple. Now we got here the division algorithm. From the division algorithm formula, the dividend equal to divisor into quotient plus remainder. However, the remainder is 0. We are not going to be take the remainder. So the dividend is what? X cube minus 3x square. Now 3x square minus 9x minus 5 equal to divisor, that is x plus 1 into quotient is what here? X square minus 4x plus 5. Minus 4x minus 5, sorry, minus 5. Yes. Now in this case we have to split the middle term as we done in the before. Okay, that's what we are going to do it here. Let us see. For that, what we need to do it? The first and last term product. We have to multiply the first term and last term in this. X square into minus 5 minus 5x square. This minus 5x square we have to write as the product of any two numbers. The product of two numbers. What are the product of two numbers? I can write that here 1 5 is 5. X into x, x square. So here it is a minus 5x square. 1x, 1 5 is a 5, x into x square. But here minus x square, minus 5x square, no, where we have to put the minus, that is very important. If you put minus here, 5x minus, if you add or subtract these two terms, we have to get the middle term. That is very important here. If you add or subtract these two terms, we have to get the middle term. So 5x minus 1x is 4x will get, but not minus 4x will get. So here it is minus 4x. So this minus definitely we have to put here. So where we have to keep the minus, that is also very important here in this case. If it is all plus terms, so need not to worry. If there is a definitely here minus term in the middle term, there we have to think where we have to keep the minus between these two factors. Okay. Then here plus 1, here minus 5. Plus into minus is minus 1, 5 is a 5. X into x square. It is balanced, no? So minus 1x minus 5x. 1x minus 5x is minus 4x. So here x plus 1 of here x square. This will write as a x square minus here minus 4x I will write as a plus 1x minus 5x. Instead of minus 4x I am writing as a 1x minus 5x and minus 5. So in this what I am going to do it, I am going to be dividing into two parts. So two term as a one part. So x plus 1. Here I am going to be taking here in this x as a common factor. X I am going to be taking out the common factor. So the first x will be left in this because out of two x's, one x will be left. Here only one will be left. One x already I took common. Then here minus 5 we can take out common so that x plus 1 will be left over. See that this both the terms are same again. So I am going to take the common factor of that both x plus 1 so this x plus 1 I am going to be take out common, then x minus 5 will be left over. X minus 5. So these are the three factors. So these are the three factors of this. Therefore, the factors of x cube minus 3x square minus 9x minus 5 are x plus 1, x minus 5. If you go for trial and error method, what happens? See that at x minus 1 you will get 0. And at p of 2 and p of minus 2, p of 3 and p of minus 3, p of 4 and p of minus 4, you will never get equal to 0. At p of 5 equal to, you will get 0. That becomes a very lengthy process. So that I told you this division method. In this division method, if you practice this division method 2 to 4 times, you will be perfect in this and it will make it easy again. It is helpful for the 10th class also. So practice in this way. So the remaining two problems from the 7th grade, you complete. I go for next, that is 8th question and 9th question, 10th question. There are only 3 more questions left to complete this exercise. So let us start that. Here the 8th problem is that ax square plus bx plus c and bx square plus ax plus c have same common factor x plus 1, then show that c equal to 0 and a equal to b. Here they have given two polynomials. Let us assume that one of the polynomial as a f of x here, that is ax square plus bx plus c, and the other polynomial is g of x, that is equal to bx square plus ax plus c. So here they have given that x plus 1. Here x plus 1 is a linear polynomial. It is a common factor. It is a common factor of f of x and g of x. Then here we know that if x plus 1 is a common factor of f of x and g of x, then f of minus 1 equal to 0 and f of g of minus 1 equal to 0. That means here at the place of x we are going to be substitute 0, minus 1 and minus 1 in the both the polynomials. That means here f of minus 1 equal to 0 and g of minus 1. Here f of minus 1 and g of minus 1 both will be equal to 0. The f of x I am going to write here in the place of f of x, that is ax square plus bx plus c, that is equal to here bx square plus ax plus c. In the place of x I am going to substitute minus 1 in the both the places because x plus 1 is a common factor. So a into minus 1 whole square plus b into minus 1 plus c, that is equal to b into minus 1 whole square plus a into minus 1 plus c. So what happens, see, a into minus 1 whole square in the sense a into 1 plus into minus minus b into 1 is minus b plus c, that is equal to b into minus 1 whole square is plus 1 plus into minus minus a into 1 is a plus c. Here a into 1 is a minus b plus c, that is equal to b minus a plus c. So what I am going to be doing, what we have to do it, that c equal to 0 and a equal to b. This is what we have to show that. So to show that, what I am going to be doing it, see, here this c I am going to bring this side. So what happens here, a minus b plus c equal plus c, and this plus c equal minus c, that equal to b minus a. Here plus c minus c get cancelled. So c made it cancel. Then what is left here, a minus b equal to b minus a. So here a's will bring one side and b's will send one side. So a plus a equal to b plus b will be left over. Then what happens here, 2a equal to 2b. 2 get cancelled where a equal to b. One of the statement as said true. Then what we have to do it here, see that in the f of x, in the place of x, if you substitute minus 1, you get this. Actually what, a minus b plus c. If a equal to b, if we substitute and equation number 1, like we have to assume this is as a equation number 1, and this if you assume like equation number 2, either you substitute in the equation number 1 or 2, that will get same. That means here a minus b plus c equal to 0. So in the place of a I am going to be substitute b now. Here there is a, so I substitute b, b minus b plus c equal to 0, that plus b minus b get cancelled, c equal to 0. So both the statement as proved here. So as proved, completed. No. So let's go for 9th question. Simple. Or not, what you do it first, f of minus 1 equal to 0 you do it, then g of minus 1 equal to you do it, then you will get two equations, equation number 1 and 2, so that you won't get a doubt that by substituting a equal to b in the equation number 1. Then go for the 9th question. Here also they have given a two polynomials that, let me read that first polynomial, p of x equal to x square minus x minus 6, and the next polynomial g of x equal to x square plus 3x minus 18, having a common factor x minus a. Having common factor x minus a, then we have to find out the value of a here. So let us find out here, x minus a is a common factor of f of x and g of x. Then here f of a equal to 0 and g of a equal to 0 we have to get. So here let us take it, that is f of a is equal to g of a. So what is f of x first? X square minus x minus 6, that equal to here g of x is x square plus 3x minus 18. In the place of x we are going to put a here. So a square minus a minus 6 equal to a square plus 3 into a, 3a minus 18. Simple that variables all will send one side and constant numbers will transfer to the other side. So here a square minus a already there in the LHS side. This plus a square become minus a square. Here plus 3a become minus 3a, that equal to minus 18 plus 6 become minus 6. Here plus a square get cancelled. 3a, here minus 3a and minus a is minus 4a, that equal to here minus 18 plus 6, that is minus 12. So minus minus get cancelled at the both the side. Here 4 if you transfer this side, a equal to 12 by 4, 4 1s are, 4 3s are, where a equal to 3. Got a equal to 3 here. So that is what we need to find out the a value. So we have the last question of this exercise now. Let us find out the last question. That is division. that is division of polynomial. Already we have done in the 10th bit. See that they have given one polynomial p of y, because the polynomial given in the terms of y cube minus 2y square minus 9y plus 18 have a common factor. That means we are y minus 3 is a factor of p of y. Here y minus 3 is a one of the factor of p of y. That is, if y minus 3 is a factor of y cube minus 2y square minus 9y plus 18, then find the other two factors. We have to find out the other two factors of this polynomial. So we'll find out by the division method. As we are aware about the division method, as I told you 2-3 times. So let us see this. The polynomial, the degrees are in the descending order. Let us write that y cube minus 2y square minus 9y plus 18. So the rough work is very important here. The rough work, I am going to do it here. Yes, first step is what here? That is y cube. Y cube by first step here y. Okay, y and y get cancelled here. 2 y's out of 3 y's, 1 y is get cancelled. 2 more y's will be left. That is y square. So the y square here is the quotient place. Now this 2 we need to multiply. Y square into y, that is y cube minus 3 into y square minus 3y square. Now we have to multiply with minus to the second polynomial, because to get cancel this 2. Now here 3y square minus 2y square is 1y square minus 9y plus 18. These two terms we have to take it down. So the second step is 1y square by, we have to divide by first term, that is y. Y and y get cancelled, so 1y is left now plus 1y. We have to multiply this 1y into y, 1y square minus into plus is minus 3 into y, that is 3y. Here minus, it become a plus. This 2 get cancelled now. 3y minus 9y is minus 6y plus 18. Okay, again we have to do the same process. The third step is that minus 6y by y get cancelled, that equal to minus 6. Here minus 6. With minus 6 we have to multiply these two terms. Minus 6 into y, that is minus 6y. See that these two terms will get same always. Minus into minus plus, that is 18. So it become a plus and it become a minus here. So plus 6y minus 6y get cancelled and plus 18 minus 8 get cancelled, that equal to 0. Now after doing this, we have to apply the division algorithm formula, that is dividend equal to divisor into quotient plus remainder. That is equal to here y cube minus 2y square minus 9y plus 18. This is equal to what actually? The product of these two, y cube y minus 3 into y square plus 1y minus 6. So here if you see, you can split this middle term of the quadratic polynomial. So splitting middle term, already I told you that. So what we have to do, that splitting middle term, we have to find out the product of first and last term, that is minus 6 into y square minus 6y square. And this minus 6y square we have to write as a product of any two numbers, but the two numbers if you add, we have to get the middle term. That is the condition. So as we can write here, 2 3s are 6. Yes, and y into y square. 2 3s are 6, y into y square, 6y square. And here there is a minus actually. Where we have to put the minus? See, if you put the minus here, 2y minus 3y is minus 1y you will get. But here it is a plus y. So this minus we have to put here. So 3y minus 2y is plus 1y. It is balanced now. So we have to check the balancing. Y minus 3 of, see that what I am going to write here, y square. This 1y I will write as a, I will split as a minus 2y plus 3y minus 6. From these two terms and these two terms, I am going to be take out one of the term as a common in this. So 1 minus 3. So in that, in these two terms, I will take y as a common factor. So y minus 2 will be left. Plus 3 I will take out common. So y minus 2 will be left over. Y minus 2 and y minus 2. So here y minus 3. Y minus 2 I will take out common. So y plus 3 will be left over. See. So y minus 3 is the one of the factors already given. The other two factors, therefore, the other two factors of polynomial y cube minus 2y square minus 9y plus 16 or y minus 2 and y plus 3. So this is the answer. Now I hope you understood this exercise. Practice well, then only you will be perfect in the factors theorem and remainder theorem. The remainder theorem in exercise 2.3, the factors theorem problems are in 2.4. So both the exercises are very important. Mainly this chapter is very helpful in the 10th class. So keep practicing and keep gain the knowledge. Thank you for watching this video.